So we want to express this expression in terms of positive exponents only. So I always say, let's start from inside, simplify, then we can move on to the outside. So negative a squared over 2. There is no other a's or numbers. If I move this b raised negative 2 to the numerator, it would become b raised positive 2. So negative a squared, b times b squared is b cubed, divided by 2 raised negative 1. I'm going to write that negative inside the parentheses as negative 1, so that I can apply the exponents to each of the terms. So the outer exponent would be applied to each of them. So negative 1 raised negative 1. If we have a squared raised to a power, you simply multiply the powers. So a raised 2 times negative 1 is negative 2. B raised 3 times negative 1, negative 3, divided by 2. Negative 1, if you raise it to an even power, the sign's going to go away. In the sense, if you square it, if you raise it to the 4th power, the negative is going to go away, you'd simply have positive. But we have an odd power, even though it's negative, doesn't matter. We have an odd power, so negative a raised negative 2, b raised negative 3 divided by 2. So I'm going to move both terms to the denominator because we want the answer expressed only in positive exponents. So if I move a raised negative 2 from the numerator to the denominator, I will have a raised positive 2, b raised negative 3 from the numerator to the denominator, b raised positive 3, and I'll have 1 in the numerator. Does that make sense? So it really doesn't matter whether you move these to the denominator or to the numerator. First step would be to simplify. So I'm combining all the x terms together, the y terms together, and the numbers together. And from last time, if I have x raised m over x raised n, the answer is x raised m minus n. So you have 2 minus of minus 1. Same argument, y raised 1 divided by y raised 3 is y raised to the power of 1 minus 3. I'm not going to change the exponents yet. Because I have negative 1 on the outside. So I'm going to apply that negative 1 to each term. So 5 raised negative 1, x raised negative 3, and y raised positive 2. 3 times negative 1, negative 3, negative 2 times negative 1, positive 2. There is always a 1 in the denominator. Every number has a 1 in the denominator. We just don't write it all the time. So I have 1 in the denominator. Move 5 raised negative 1 to the denominator. I get 5. Since it has a negative exponent, x raised negative 3 has a negative exponent. Move it to the denominator, I will get x raised positive 3. And in the numerator, we will have y squared. Any questions? So before we apply the power or the exponent inside, I'm going to simplify. Combine the numbers together. So 4 over 1, x raised negative 2 over x raised negative 3, y over y raised negative 4, and square. So 4, negative 2, x raised negative 2 divided by x raised negative 3. M, so m minus n, minus 2 minus of minus 3. M here is 1 minus of minus 4. And raise the entire expression to the power of 2. So 4 x raised negative 2, negative times negative 3 is 3 minus 2. So I get 1. 1 minus of minus 4 plus 4. 1 plus 4 is 5. And raise it to the power of 2. So apply the exponent to each of the terms. So 4 squared, x squared, and y raised 5 times 2, 10. So I'm applying that exponent to each of the terms that are inside. So 4 raised 1, so 1 times 2, 2. 1 times 2, 2. 5 times 2, 10. So 16 x squared y raised 10. We want to first combine like terms, so 3 over 1. There is an x squared in the numerator, no x term in the denominator. So I'm just going to put 1 there. Y cubed or y raised negative 5. The entire thing raised to the power of negative 1. So 3 x squared. M is 3, n is negative 5. So since we have y cubed divided by y raised negative 5, we will have m minus n. So 3 minus of minus 5 raised to the power of negative 1. So 3 x squared, negative times negative, positive 5. 5 plus 3, 8. So y raised to the power of 8. Now that I've simplified the terms inside the parentheses, I can apply the exponents from the outside. So 3 raised negative 1. 1 times negative 1. 2 times negative 2 is x raised negative 2. Y raised 8 times negative 1, negative 8. They all have negative exponents, and we want the answer only in positive exponents. So we all know that there is a 1 in the denominator of every number. So if I move 3 raised negative 1 from the numerator to the denominator, it would become 3 raised positive 1, which is just 3. If I move x raised negative 2 from the numerator to the denominator, I will have x raised 2. If I move y raised negative 8 from the numerator to the denominator, I'll have y raised positive 8. Once I bring all the terms down, I'll be left with 1 in the numerator. So the same process can be applied in different ways. But there are other rules that we talked about last time. So one of those is multiplication. Suppose I have identical bases, which in this case is x. What do we do to the powers? We add them. So we will have x raised 8 plus 2, which is x raised 10. So anytime we have identical bases, we simply add the powers. Same logic over here. Identical bases, why? But it is in division, or they are in division. So numerator exponent minus the denominator exponent, which is minus 5. So we got y raised negative 8. What should you do in a problem like that? Which means, what should I do? Multiply the two powers, so I've got to take care of that first. So x raised to the power of 3, I will have x raised 6, multiplied by x raised 8. Bases are identical, so what do I do to the powers? I'm going to add them. So 6 plus 8, which will give me 14. So the answer is x raised 14. So first step is to apply that exponent. So x raised 3 raised 2 would be x raised 6. Y cubed times x raised 4. We can move the terms around so that the x's are nearby. So x raised 6 times x raised 4 times y cubed. The bases are identical, so you add the powers, 6 plus 4, multiplied by y cubed. 6 plus 4 is 10. So the answer is x raised 10 times y raised 3.